Welcome to another video on my Raspberry Pi 1 running Raspbian Linux, connected to a network for VNC, virtual network computing, serial cable for data acquisition via use of the scientific language Octave. Also connected to a bed cable for a breadboard and a probe for the oscilloscope for, in this case, serial signal. Also connected to Raspberry Pi camera for somewhat delayed, few seconds, live stream. Then the band cable goes to this breadboard and focus is on this particular piece of the breadboard with fischertechnik LDR, and you already noted the fischertechnik support for the Raspberry Pi camera. Then a normal LDR light dependent resistor, MCP 3008 analog to digital converter. This gives analog values, this one and this one as well. And Raspberry Pi is only digital, so an analog to digital converter via serial peripheral interface SPI protocol. So what I want to do is once again read the values and try to log them into a data file with nice and proper values. Also, because this is only to see on screen, I reconnected this LED, these LEDs, to port 7, which is already part of the algorithm but commented out, and I want to change that so you can see something happen on the breadboard instead of just something on screen. So with that said, let's go to software and see how things can be changed. So this is the screen for software. VLC stream, which you can see right here in VLC, and right now I still have to adjust the decoder to make use of this particular LED. I have to set it straight a bit. Alright, that's one thing. Then Pi scope for SPI as well as serial, and right now it's not doing a thing. And Pi scope is giving some issues, but we'll see how this works out. I'm very curious. Then decoder with the LED that is hopefully going to change. Oscilloscope. Clock, data, chip select, and RS232, that one probe that I already mentioned. Then the camera, and this is only SPI probes. And Minicom. Minicom, then the schematics. If you have watched previous videos on analog to digital conversion, you may recognize this. And then Octave, ready to hopefully correctly take out LDR2. But does it work? Well, this works so far. If this is going to work, I don't know yet. Anyway, enough talking, let's do something. And that means starting the software. Oh, and then it would be very nice. In Minicom, everything works nicely. The point is, in Octave it doesn't. So let's run Octave, press F5, and then things, yeah, permission denied. Right, that's not a thing. For some reason I can no longer freely open the T2 USB interface. And this is one, or no, I opened one, so I need to open it. So yeah, but how to open it? By making it my own instead of root, and that is very strange. I still don't know why it can't open it anymore. Anyway, this is mine now, so now it opens it. And you see here the signals go, at least on the RS232 line. So let me improve that. At least I hope so. Oh, it's now set to 1 second. Increasing. But here are no signals going. So that's kind of worrying. Why aren't they going? Alright. But what I still need to do is accessing this pin 7 high, pin 7 low, but is that really working now? No, it's not, because I disabled it. So end of this one. Let me then also end, at least that is what is supposed to be, ending this program, and rewrite this. And what I intend to do with the values, so I read LDR channel, and that value is supposed to be larger than, say, 250. So if it is larger than 100, I want to light up the LED. So let me do that. First of all, if LDR value larger than 100, then GPIO output 7 true. Next, time dot sleep for 1 second. GPIO dot output 7 false. That should do it. Will this work? I'll very soon find out. So let's go and see. Starting software, what happens? And right now it won't do anything because everything reads 0 to my surprise. So why does it read 0? Not supposed to be. Last time this worked nicely. So I have to check a bit of the wiring, I guess. Okay, now things work better, or worked better. I saw a value pass. Okay, SPI does work. LDR value. And I may have to rewire this. This is set to larger than 100. So that in itself is alright. So why are the values not nice? I want to see that LED go, and unfortunately now I think of showing you everything. So let me bring the camera a bit down so only the part of the circuit that is doing alright is shown. Yes, it is 250. It was 250. So something is with the wires. Okay, now it is. That is very good. But yet the LED doesn't do a thing. And I see no signal at all on SPI anymore. So why is that? Let me once again pull the plug and pull the plug. So power off, power on. This definitely should work. And by the way, 7 is definitely down here. So I should be watching or looking at a blinking LED, which is not happening. Which is not happening at all. So let me check on that as well. Output 7, true and false. And I am using pin, or do I make a mistake? GPIO out, that is correct. All of this is correct. Still working. What I can also do, of course, interrupt for a moment and say print LED on. That way I do know that it is being done. So once again, go and LED on. Oh yes, definitely. So am I missing something? Not that I can see. I have to check the LED then. Right, and then it turns out to work after all. The only thing is that there was a piece of wiring here not correct. So now, while LDR value is clearly over 250 to 46, the LEDs are nicely working. So let me pull up this screen and you see this one, and here nicely working. So the wire goes from here to here, then green wire, yellow or orange wire and orange wire, and in that way to this. So it's not a direct connection. Could be, but for now isn't. Anyway, that is to be seen. And here you see SPI working nicely, LDR working nicely. Then why is nothing shown here? I have no idea. It does work. I checked also the probes if they are correct. Looking here, everything works nicely. So these are the wires 19, 11, 21, 23 and 24 that I use for SPI, and that's all there is to know for now. Going back, back to Octave then. That still has to be working, get working. So, knowing now that some issue with data is there, a delay in writing to a data log. So what is the name of the data log to be exact? No, I have to look in, not here, I have to look in the code for Octave, of course. And that is datalog.txt, obviously. So, and that is RPI FT. Oh really? No, it is MCP, and that is alright. So this actually means that nothing is written, nothing correctly is written, because this value doesn't make sense. And it's only LDR, not LDR2. So this is not being written. And these are the same data. So I compare S2 with data2. Oh, and I make a mistake here, I think. No, these are 4 characters. But I do make another mistake, I think. Let me see. No, I do a string compare. That is correct. I do not do a vector compare, a string compare, and that works nicely. So a string compare with a string, then 4 characters of the data. If that is correct, oh wait, if it is correct, I have to display something that is different from here. So I make it equal to. And LDR2 on screen, and then this should be working out as well. New line and space, so something should work out. Let's see if that does. Does data2 do anything, by the way? If I look at here, LDR2 says 0. That is not intended to be. So let me put a thumb on it, and now LDR2 is changing values, or was changing values anyway. I am holding now both LDRs. And I let them both go. What difference does it make? Not too much. But 0 is a value as well, so I'll let that be. Data2 is 5, 7. Okay. That means that it should be written anyway. Let me end this. Okay, that works. Now and what should this give? So it has told me that I should wait a little bit before things work out. Well, it is 39 and timestamp is now 35. Let's see if it works out anyway. and this is not good. So somehow this doesn't really work out. Do I see somewhere? No, this is only flag. And do I see somewhere else? Data 2 is I do not see any equal except for this one again. And how is it written in the code? Just like this. Oh wait, wait a second. This is suppressed. This is suppressed. Is that making a difference? Because this is being printed on screen as well. It is being printed as well as LDR1. So that should not be the culprit. Definitely not. LDR2 being printed as well. So something is not quite the way I like it. Not being written the way I want it. So with limited time and this still going on with some nice values, 237 and 12 and then 0 for some reason. The Pi scope giving nice readings, but on the oscilloscope only the serial line gives readings. Oh, here now I see here some occasional readings as well. Very, very occasional. Not what I expect. But considering this a part of the code, it should work, no doubt. Only it doesn't for some reason. But I'm afraid that is something for next time. And well, I don't have to wait till next time, apparently, because as you can see now there is LDR2 as well. The readings are not making sense, but LDR2 is being written. So next time, yeah, why are the values the way they are? That is very challenging. But at least I know the algorithm is now correct. So that's the end for now. LEDs properly working, and LDR2 being written to file, SPI working, although I haven't seen anything on the oscilloscope properly. On the serial port, yes, it works. So kind of successful. Thanks for watching. If you like this video, please subscribe to my channel and give the video a thumbs up. Leave a comment or suggestion. And You can also follow me via Instagram and Twitter. Please show your appreciation by making a donation via either PayPal or wire transfer, banking, easy from within Europe. And you can also decide to become a patron, and depending on the pledge, may have your name mentioned on my website and with my videos. This is to be continued. Have a nice day and bye bye.